Hi, welcome to lecture 9. In this lecture, we want to leave theoretical concepts and enter to operational fields. We want to configure Eigrp. In this lecture, we start with basic commands and continue in the future lectures with more advanced configurations. Therefore, after this lecture, I expect you to be able to configure Eigrp for IPv4. Let's start our today's mission. Now let's start our configuration. As you could see, I want to do my configuration with GNS3. I'm sure all of you know about GNS3 and use it before, but for those who are not familiar with GNS3, GNS3 is an emulator. It emulates Cisco devices for you. GNS3 could also emulate virtual machines, Juniper routers, Cisco firewalls, and many other platforms. Installing GNS3 is very easy process. You have to make an account in GNS3's website, which is www.gns3.net or .com. I'm not sure. Both of these addresses will be usable. I don't know, .net redirect to .com or .com redirect to .net. I think .net redirect to .com because it was the previous address of GNS3's website and now it changes to gns3.com. Anyway, when you enter GNS3's website and make an account, GNS3 lets you to download the sources. There are many sources for you. You could download the all-in-one version, which include many packages like WinPickup, Wireshark, and other packages. Installing it is very simple, just some few next clicks and finish, and GNS3 is installed. After GNS3 is installing, you have to do something. First, you have to import an iOS. Note that using iOS of Cisco requires licenses, and you have to have the right to use these iOS files. To import an iOS, you go to the Edit menu and select Preferences, and here from Dynamics iOS routers, you select New and import your iOS image and assign an idle PC. Idle PC is the free process of your CPU to let your CPU to work with GNS3 without any heavy load. I will show you my task manager after starting the routers, and you will see that the CPU usage of my system will be arise and again come down because I set the idle PC before. After importing the iOS router and assigning idle PC, GNS3 is ready to use. The only thing you need is to import your routers by selecting this item and drag and drop your routers and put them in the topology. And now we're ready to start our routers. Now, as you could see, my router 1, router 2, and router 3 down, and I want to start. Before I start the routers, I want to show you my task manager. Yes, this is my task manager. As you could see, only 22% my CPU is using. After I start my all routers, you will see that my CPU usage will arise, and Dynamics exe, which is the process of GNS3, arise my CPU usage. Since I assign idle PCs before, after a few seconds my CPU usage come back to normal. If you do not assign the idle PCs before at the importing iOS image, you could do it now. You could see my CPU usage come back to normal. If you didn't do that, you could do it here by right-clicking on the router and select the idle PC and computing the idle PCs and show you a list, and you could select an idle PC number from the list. The asterisk one potentially is better. You select one of these and click OK, and if your CPU come back to normal, everything is okay. Otherwise, you have to repeat this phase again until CPU usage come back to normal. Now we start our router and everything is okay. My CPU usage is normal and I want to connect to the routers. GNS3 is able to use many console applications. The default is PuTTY. You could change it with other ones. Again, from Edit menu and Preferences, in General tab, you could select console applications, and from this menu, you could use Secure CRT, PuTTY, Super PuTTY, Telnet, TerraTerm, XShell, and Zoc version 6. I choose Secure CRT, which is my favorite application. And after you change it, you have to click Set and OK. And now, when I click here to launch my console application, my application will run, and it is here. I want to show it to you. And as you could see, the Secure CRT benefit is that it is tabular and you have 3 of your routers in a single window. Clear my screen, I click on edit menu and clear screen. Now my routers are ready to configure. As you could see, I select 2 range of networks, 192.168.10, 192.168.20 between 2 routers. In this simple scenario, I want to configure Eigrp and show you how to use it. I start from router 1. As you could see, the fast Ethernet 0/0 between router 1 and router 2 and fast Ethernet 1/0 between router 2 and router 3 are connected. Now I want to start my configuration. In router 1, I go into global configuration mode with configure terminal command first, and then select the interface fast Ethernet 0/0. I assign the IP address 192.168.1.1, 255.255.255.0, and no shutdown. In router 2, again, global configuration mode, interface fast Ethernet 0/0, IP address 192.168.1.2, 255.255.255.0, and no shutdown. To check the connectivity between router 2 and router 1, I issued do ping 192.168.1.1. The connection is okay, so I go to the other interface fast Ethernet 1/0, IP address 192.168.2.1, 255.255.255.0, and no shutdown. And router 3, interface fast Ethernet 1/0, IP address 192.168.2.2, 255.255.255.0, and no shutdown. And again, to check the connectivity, do ping 192.168.2.1. Okay, now I have the connectivity between my routers. So I start my Eigrp configuration. I will save this configuration commands in a text file and save my Genus3 scenario for you to could use it for further studies. Again, I clear my screen to show you better. First of all, let me tell you, Eigrp configuration is very easy. We have only 2 steps. First of all, you have to enable Eigrp on your router with the command router Eigrp and your AS number or ASN. I want to remind you that AS number is one of the neighborship factors. So you have to configure it the same in all of your Eigrp routers that want to be neighbors. Okay, by this command, I enable Eigrp on my router. The second phase or the second step is advertising or enabling interfaces with Eigrp. Before doing this, I want to capture the packets which are going in this link. I start the capture. I select the wrong interface. Sorry. I want to select router 1 interface fast Ethernet 0/0. Let me put it here. And now I'm here. I want to show you that what would happen when I issue the second command. Now I want to advertise my 192.168.1.0 with the command network. So I issue network 192.168.1.0. Here we have to use wildcard bits, as you could see. Wildcard are the reverse of subnet mask. I mean, anywhere in subnet mask is 1, in wildcard is 0 and vice versa. For complete 1 and 0 octets, it is very easy. An octet which is 255 in subnet mask, the wildcard would be 0 and vice versa. But in other subnet masks like 128, for example, it may seem too hard to calculate the wildcard. I want to tell you a very simple formula. Any item or any number you have in your subnet mask, put it in this formula. Minus it from 255. So, for example, if you have 128 in subnet mask, minus it from 255, and it would be 127. 127 will be your wildcard mask. And you could calculate any wildcard mask with this formula, only minus it from 255. So, my subnet mask of this network is 255, 255, 255, 0. Therefore, my wildcard mask would be 0, 0, 0, 255. You will see that after I push the enter, router 1 starts to send hello packages on the interface, which is the IP address is in this range, and it is fast Ethernet 0/0. Therefore, issuing the network command will do two things. First, advertise the network of 192.168.1.0, which means that, hey, my neighbor, you could reach this network from me. And the second one is sending hello messages and other Eigrp packets on the interface, which is the IP address is in this range, and we call it enabling this interface with Eigrp or Eigrp enabled. So I push the enter, and you see that Eigrp starts to work and sending hello messages. Since the router 2 is not configured yet, there is no any reply and no neighborship will form. Okay, let me minimize it and continue my configuration on router 2. On router 2, again, router Eigrp 1, and now in this router we have to issue two commands for two networks. Remember that you have to issue network command only for directly connected networks of this router, not any other network. And on the interfaces, you want to enable Eigrp on them, only on these interfaces. So I issue network 192.168.1.0 0.0.0.255, again wildcard mask. And now I expect my Eigrp neighborship form. You see that the console message me dual diffusing update algorithm. The severity of 5, neighbor change, and neighbor 192.168.1.1 on fast Ethernet 0/0 is up. New adjacency. The neighborship between router 2 and router 1 is formed. Now let's continue our configuration. 192.168.2/0 with the same wildcard mask, and on router 3, let me clear the screen again, exit router Eigrp 1, network 192.168.2.0, and now I expect to neighborship becomes up between router 2 and router 3, and you could see that it is done. The only basic configuration to running Eigrp is only these two commands, router Eigrp and network. And now we have Eigrp in our network. How could we test or troubleshoot our Eigrp topology? I say some basic troubleshooting commands, and we will continue with advanced one in the future lectures. So, first of all, I want to see that my routing table is correct and the router 3 now knows about network 192.168.1.0. So I issue show IP route command. And as you could see, there is one route with D sign. D means Eigrp. See that? D these EIGRP. 192.168.10/24 90 is the administrative distance of our routing protocol. As you could remember, EIGRP was 90, and this is our metric. Via next hop is 192.168.2.1, and it's the time, and it is the outgoing interface. We could customize our show IP route command and customize it with show IP route and show me only EIGRP routes, not any other route. And you could see that we have this line again. So first step, checking show IP route. Now let me tell you some other troubleshooting commands. First of all, again, let's clear our screen. And now, first of all, if you see the routing table and you see that the route you've expected is not in the routing table, we have some troubleshooting commands. First of all, you have to see that the expected interfaces are EIGRP enabled or not. Let me do it on router 2, it is better. Clear the screen. First of all, show IP EIGRP interfaces. This command will show you EIGRP enabled interfaces. Now we issue. And you see that the fast Ethernet 0/0 and fast Ethernet 1/0 are EIGRP enabled. Okay, so the expected interfaces are okay. After that, we could issue show IP protocols. Show IP protocols will show you the routing protocols which are enabled on your router. And you could check some parameters. EIGRP routing protocol is EIGRP, and this is the AS number. This could be the first item you check it. These are the K values from K1 to K5 interfaces, which are EIGRP enabled, and the routing is done for these networks. These are the results of issuing network commands. Administrative distance for internal routes is 90 and for external route is 170. So we learned 3 commands: show IP route, show IP EIGRP interfaces, and show IP protocols. The next command will show you the EIGRP neighbors, and we saw it before. Show IP EIGRP neighbors. These are my neighbors, 192.168.2.2 and 192.168.1.1. I have 2 neighbors, router 1 and router 3. And our neighborship is formed on these interfaces. And the hold times are these, and the hop time is this: SRTT, RTO, queue count, and sequence number. And finally, show IP EIGRP topology. This command will show you our topology table, maybe the important information which is inside. The output of this command is the successor and the feasible successor route and the distances. When you issue this, you see that 192.168.1.0/24 has 1 successor. The feasible distance is this and connected via this interface. You see a code here. This is passive. Don't worry, exceptionally in this situation, passive means everything is okay. It means that router passively searches for this route, and therefore clearly it means that router does not look for this route and it is in the routing table and everything is okay. If you see this is active, it is not a good sign, and it means router actively searches for this network. There is another situation which is SIA, stuck inactive, which I will tell you in a separate lecture. So we learned 5 basic commands for troubleshooting EIGRP: show IP EIGRP interfaces, show IP protocols, show IP EIGRP neighbors, show IP EIGRP topology, and show IP route. We could customize show IP EIGRP topology for a specific network. And for example, we say that 192.168.1.0/24, and we see more details about this. And as you could see that this is in AS number 1, the topology interior for this, the successor, it has 1 successor, the feasible distance is this, and let me see what is more important. Route is internal, minimum bandwidth is this, and the total delay is 100 microseconds, reliability, load, minimum MTU, and hop count. For this lecture, we're done. So just for review, for enabling Eigrp on our router, we have to issue router Eigrp with AS number command, and after that network commands, and we learn 5 troubleshooting commands. Now it's summary time. In this lecture, we learn how to configure Eigrp and some basic troubleshooting. I hope this lecture helps you to improve your knowledge, and see you in the next lecture.